use the gradient together with the y-intercept to sketch the graph. Alright? So, for 1.1, our equation is y equal to 2x minus 3. I want you to pay attention very carefully because I'm going to sketch now using the gradient-intercept method. So, first thing, this minus 3 is our y-intercept. Okay? That minus 3 is our y-intercept. So we go to the graph. Okay? We locate where minus 3 is. And minus 3 is here. That's where my y-intercept is. Okay? Then, this 2, this one here, okay, let me use a different color. This 2, what it means is that for every 2 steps you make going up, you are going to make 1 step in a horizontal direction. So you make 2 steps in a vertical direction and then 1 step in a horizontal direction. So it's like this. You go 2 steps up, at the same time you go 1 step down. Remember, the gradient is equal to y2 minus y1 over x2 minus x1. And this you can write it as a change in y over a change in x. So this 2 here, it means that if you jump 2 meters up in a horizontal direction, you are going to jump 1 meter, which means 2 divided by 1 will give you a 2. Okay, I'm going to repeat that. The gradient, this one here, what it means is, in terms of a change in y over a change in x, remember y represents a vertical distance and x represents a horizontal distance. So the 2 means if you jump 2 meters up, you are gonna move 1 meter in a horizontal direction. If you jump 4 meters up, you are gonna move 2 meters in a horizontal direction, because 4 divided by 2 will give you a 2. If you jump 6 meters up, it means in a horizontal direction you have to jump 3 meters, because 6 divided by 3 will give you a 2. So, if we are here, okay, at minus 3, we are at minus 3, right? It means that I'm going to move 2 meters up, okay, because remember, I'm using my gradient-intercept method. So, if I move 2 meters up, okay, I'll get to minus 1. Alright? And then I need to move 1 meter to one unit to my right, which means I'll get here. So my next point is gonna be here. Okay? Which means I moved 2 meters, I moved 2 units up from minus 3 to minus 1, and then moved 1 unit to the right. Okay? Now I'm here. Then I need to move another 2 units up from minus 1 to 0 and then to 1. So I'm now here. But I need to move now 1 unit to the right, so I'll get to that point. Alright? So forget about
Sure.
yes.
Would that be like last year? 2 would be the rise and 1 would be the run.
Okay, it will be 2 will be the rise and 1 will be the run.
Yeah. Okay, thank you.
Yeah. 2 will be the rise and 1 will be the run. So we are saying we are moving 2 units up and one unit to the right. Okay? So from here, we move 2 units up, which will get us to positive 1 and 1 into the right. So we end up getting to that point. And then we move another 2 units up to positive 3 and 1 unit to the right. We end up getting to that point. Okay? So, if you want to calculate the gradient, if I choose, say, that line there, okay? 3 minus 2 gives me 1. Okay? And 3 minus 1 gives me 2. So, it means here I have got 2 units and here I've got 1 unit. 2 divided by 1 will give us 2, which is the gradient. Okay? And then I can go further, right? Another 2 units from here up to 5, okay? And then 1 unit to the right, I'll get to that point. Then the next thing, since it's a straight line, you now need to take a ruler and then you need to draw. Okay? You need to take a ruler and then you draw. In my case, I don't have a ruler, so I'm going to try and use that. Okay? So it will be something like this. So that will be my straight line. Okay? And then you need to label it. Right? Let me use blue there. So my equation, I'm going to label it here is y equal to 2x minus 3. Okay? Any question? Okay? If the gradient is positive, the straight line must be slanting to the right. If the gradient is negative, the straight line must be slanting to the left. So the shape of the graph will also be allocated a mark. So generally it's 3 marks to actually sketch it. Okay? Any question? Before I move on to the dual intercept method. Right, I just want to add this to the graph. Right, if you don't have a question, let me carry on to the to 1.2, which is the dual intercept method. Now, the dual intercept method is much easier as compared to the gradient intercepting method. That's my opinion. Okay, it's much easier. All right. Now, the question here says sketch the following on the same set of axes. So we are going to sketch the equation for 1.2 on the same system of axes. All right. Now, before we do anything, we need to analyze what's going on with regard to the equation. So the equation, right? Allow me to go to the next page because it's very important. Our equation is x plus y equal to 4. So I'm going to the next page, I'll come back. Alright, our equation is x plus y equal to 4. Right? This is the dual intercept method. The dual intercept method. Now, I'm sure you are all aware that the word dual means two. Okay? The word dual means two. So we can also call it the two intercept method. And the two intercepts that we are talking about is the x-intercept and the y-intercept. Now, if you go to what I said earlier, when I started, I told you that a linear function has an x-intercept and a y-intercept. You get the y-intercept when x is 0. You get the x-intercept when y is 0 or when f of x is 0. So, in this equation, we need to determine the x-intercept. So, I'm going to find the x-intercept. To get it, I must substitute y equal to 0. Okay? So our equation is x plus y equal to 4. Now, for this question, there is no need to make y the subject or to rewrite the equation in the form y equal to mx plus c. It's not necessary. You can just substitute where there is y, you put 0 there, and you get x equal to 4. Which means the graph is going to pass through a point on the x-axis where x is equal to 4. Alright? And then the y-intercept, you get it when when you substitute x equal to 0. So our equation is x plus y equal to 4. So where there is x, we put 0. And then you get y equal to 4. So both the x-intercept and the y-intercept are equal. They are both equal to 4. Okay? Now, in terms of coordinates, the x-intercept is found at the point where x is 4 and y is 0. The y-intercept is found at the point where x is 0 and y is 4. Okay? I'm writing in coordinate form as well because sometimes you can get a question asking you to determine the coordinates of the y-intercept or the coordinates of the x-intercept. In that case, you have to write it in ordered pairs. That is an x value and a y value. X value and y value. Okay? So that's your y. This one here is the y, that's your x. That's your x, that's your y. Okay? Lines, okay? All straight lines, they pass through an x-intercept and a y-intercept. That's why we can use the dual intercept method to sketch or to draw a graph of a linear function. Okay, so all you have to do is determine your x-intercept, determine your y-intercept, and then you locate those values where they are on the graph. So for our question, our x is 4, our y is 4. What that means is the straight line x plus y equal to 4 is going to pass through a point on the x-axis where x is 4 and on the y-axis where y is equal to 4. Okay, so let's go to the previous page. So we now know, okay, let me use this color here. Now, we now know that our y-intercept is 4, our x-intercept is 4. So, if I go to the x-axis, this is where my x-intercept is. And that is where my y-intercept is. In my case, I prefer the dual intercept method when I'm drawing my straight line because it's the easiest. Okay? Now, the other thing, before I carry on, let's go to the next page. I'm going to do this for interest's sake. Okay? Our equation is x plus y equal to 4. Right? Now, I need to write this equation in the form y equal to mx plus c. I'm just adding this part. So, I'll take this x to the right so that I'll have y equal to minus x plus 4. Which means my gradient is negative. If the gradient is negative, it means that the straight line must be slanting to the left. Okay? So the gradient of x plus y equal to 4 is going to be slanting to the left after I've written it in the form y equal to mx plus c. Okay? So when I sketch my straight line, it has to be slanting to my left because its gradient is negative. So let's go back to the previous page. So here, I have already indicated where my x-intercept is, where my y-intercept is. All I have to do is take a ruler, draw a straight line passing through this point where x is 4 and that point where y is 4. It's so easy. This is the easiest method to draw a straight line. So I'm going to draw my straight line. I'll choose that one, obviously. Okay, I'm going to start at the top, right? And then it's going to be like that. That's my straight line. In fact, let me change the color of it. Okay, let me try to change the color. Um, okay, it's not allowing me to change the color. Let me go back. Okay, let me draw using this color. Okay, it's not allowing me to change the color anymore. Anyway, my straight line is gonna look like that. That's my straight line. Then I need to label it. I label it. This line is gonna be x plus y equal to 4. Okay. I hope you can see or you can understand as well what I just did there. So the dual intercept is the easiest. Determine your x-intercept, your y-intercept, plot those two on the graph, take a ruler, join those 2 points, and make sure you draw the straight line beyond those 2 points on either side. That's it. A table of values. So I'm going to talk about how to use a calculator to do a table of values. Okay, if you have your calculator, you go to mod, that's the first thing, mod, then it gives you option like this calculator gives you the option table. So you click number 7, then it says f of x equal to. Now last year, you probably didn't understand what f of x equal to, but now you understand that f of x is the same as y. So our equation is y equal to 2x minus 3. I'm talking about the first equation. So, where there is f of x there, the f of x has replaced y in the equation. Then we put 2, okay, we press alpha x, okay, minus 3, okay, then you press equals. Now, it gives you another option, it says g of x. Now, we can consider the second equation, this one here, x plus y equal to 4, as our what? Our g of x. So if we make y the subject here, it will give us y equal to minus 4x plus 4. So I'm going to say minus 4, then shift x plus 4. Sorry, it's supposed to be minus x. So that minus is not there. It's minus x plus 4. Then you press equals. Now it says start. Now start refers to the domain. Okay, that is the set of the x values. Okay, it refers to the set, because remember our x values are the input, so we need to start with the input first. Let's start at say minus 5. Okay, let's start at minus 5. Okay, press equals, then end at 5. Okay, our step, okay, by step we are saying if we start from minus 5, okay, going towards the positives, it will be minus 5, minus 4, minus 3, minus 2, minus 1, 0. So our step is going to be 1. Right? Then it gives you the table. Okay, because the two graphs are supposed to be sketched on the same system of axes. You can start by sketching f of x. So you go to minus 5 and then minus 13, you plot the points. You go to minus 4, minus 11, you plot the points and so on. And then you take a ruler, you join those points. You do the same for g of x. So you use the first column and the third column for g of x. When you do that, you should come up with the same graphs as what I have here. Okay, that's it. I hope everyone knows how to plot a graph. Okay, and then just use a ruler, you join the points, you label your graphs, and then you are done. So no one should say that yes.
While you're using the calculator, would you mind just showing how to find a trinomial? I got the right calculator, but I can't remember how you showed us to do that.
Well, remember, Celine, you are in the senior phase now. It's not no longer necessary to draw a table in your book or on a question paper. You can do that on a calculator. Do you understand me? Hello? Hello?
Yes, but I was just asking. Yes, but I was asking how to use the calculator for the trinomial.
For the trinomial, which trinomial are you talking about?
Yes, that you showed us last term.
No, okay, you see,
From the past section. It was from last term.
well, I think for now, let's not introduce any other aspect besides the linear function to avoid unnecessary confusions. Okay? We will talk about the quadratic function later
Okay.
on. Later on, when you talk about the quadratic function, that's when I will discuss the use of the calculator to do a trinomial and to solve a quadratic equation. But for now, let's stick to the linear function. Everyone must understand the linear function, how to sketch it using the gradient-intercept method, how to sketch it using the dual-intercept method, how to use a calculator to do a table of values, and using that table of values to sketch the linear function. Okay? Let's not introduce any other aspect.